Hello everyone, welcome back to my AWS Cloud Practitioner series. My name is Akash Patel, and in this video we are going to look at three very important parts of AWS: networking, storage, and database. In the previous video, we had talked about things like security, IAM, and secure architecture. Now we are moving one step further into the series that are used to build real cloud applications. So this presentation is a part of my learning journey at Concordia University, Chicago, under the guidance of Professor Dr. Victor Govindaswamy. Let's go ahead and start with the first slide. Let's see some introduction. In this part of the series, we are continue from those earlier topics like security, IAM, and architecture, and now move into networking, storage, and database service. These three areas are the base of almost every applications that runs inside AWS. If you open any real architecture diagram, you will always see some from form of VPC, storage, and database in it. AWS networking is what allowed your cloud resources to communicate with each other and also with the outside world, like your user on the internet. It makes sure that this communication is both efficient and secure, so only the right traffic gets in and out. AWS storage service are used to save all kind of data, file backups, logs, applications, content, and so on with very high durability. They also gives you flexibility so you can choose the right balance between cost and performance. AWS database service help you organize and manage data in a structured way. They allows your applications to quickly read, write, and query information as your user base grows. So by understanding networking, storage, and database together, you get building blocks needed to design real production ready AWS environment in a safe and scalable way. So now let's start with Amazon VPC, Virtual Private Cloud. So which stand for Virtual Private Cloud. You can think of a VPC as your own private network inside AWS. When you create a VPC, you are basically saying this is my own section of the AWS cloud, and I control everything inside it, like IP address, subnets, routing, and security rules. It's similar to having your own small data centers, but without buying any physical hardware. A VPC helps keep your sensitive resources isolated. For example, you might have a database that should never be directly accessible from the internet, so you can place that database inside a private part of your VPC, so only your application servers can talk to it. You can design network structures where public subnets are used for things like web servers that receive traffic from users, and private subnets are used for internal service like database or background processing systems. So with a VPC, you also get very fine-grained control over how traffic flows between different parts of your network. You control which parts can send or receive traffic from the internet and which parts stay completely internal. All of this makes Amazon VPC a key component for building a secure and well-organized AWS architectures. So let's move to the next slides. So let's see the subnet route tables and connectivity. So inside a VPC, we have a smaller section called subnets. Subnets help you divide your network logically. So we typically use the public subnets for resources that need internet access, such as web servers that users connect to in their browsers. We use private subnets for resources that should not be exposed to public, like database or internal services. Then we have route table. So a route table is basically a set of rules that divide where traffic goes. For example, if a request is going to the internet, the route table might send it to a internet gateway. So if it's going to an internal resources, it keeps the traffic inside the VPC. An internet gateway is what allowed communication between your public subnets and the internet without any internet gateway attached. Even a public subnet cannot actually reach the internet. So an NAT gateway is used when you want private servers to reach out to the internet, for example, to download updates, but you don't want the internet to be able to reach in to those servers, so it gives them outbound access while keeping them hidden. So together subnets, route tables, internet gateway and NAT gateway create a secure and well-controlled network environment for your application. So let's move to the next one. So let's see the Amazon S3 object storage. So which Amazon S3, which is one of the most famous AWS service. Amazon S3 is a object storage service. That means it stores the data as object inside something called buckets. You can store almost any type of file here, images, videos, documents, backups, logs, and much more. S3 is designed for extremely high durability, like the typical number you will see in 11.9, which is 99.999999% durability. So because it stores object rather than traditional files on a disk, S3 can scale almost infinitely without you managing any server. You just upload data and AWS take care of the result of the rest. You can control who access your data using IAM policies, policies, and encryption settings. So this make it secure for storing sensitive data as well. S3 also supports feature like versionings and lifecycle rules, so older or less used data can automatically move to cheaper storage classes over time. So this help you manage cost very efficiently. Overall, S3 is used in almost every AWS architecture because it's reliable, low cost, and flexible. It works great for backups, static website, big data analytics, and much more. So let's move to the next slides. So let's see the now we'll look at two more storage service like Amazon EBS and Amazon EFS. So Amazon EBS or Elastic Block Stores provides block level storage for EC2 instance. You can think of it as a virtual hard drive that you attached to your virtual machine. So it's perfect for things like operating system disk, application data, and database that need fast and consistent performance. Amazon EFS or Elastic File System. So EFS stands for Elastic File System, is a shared file storage service. Multiple EC2 instances can connect to the same EFS file systems at the same time, which is great for applications that need shared file access. So EBS volume supports snapshots, encryptions, and the ability to resize, giving you flexibilities as your storage needs grows. AWS automatically scales. EFS automatically scales as you or add or remove files, so you don't have to think about capacity planning. You just pay for what you use. In simple terms, the use EBS when you need a disk for one server and use EFS when you need a shared file system for multiple servers. Let's move to the next one. Let's see the Amazon Glacier archival storage. So next is Amazon Glacier, which is designed for ar- archival storage. So this service is used for data that you rarely access but still need to keep for a long time, such as legal records, audit logs, or old backups. The main advantage of Glacier is that it is very low cost compared to regular storage. The trade-off is that retrieval is slower. So when you want to access data from Glacier, it can take from a few minutes to several hours depending on the retrieval options you choose. So many organizations use glaciers to store data that they must keep for compilation, com- compilation, or historical reason, but don't need to look at often. So by moving old or rarely used data to Glacier, companies reduce their overall storage bill significantly while still keeping their data safe and durable. So Glacier is your long-term cold storage solution in AWS. So let's move the next one. So now let's move into the database world in AWS. So AWS offers a wide varieties of managed database service because different application needs different types of data storage. So you have traditional relational database and modern NoSQL database among others. Relational database stores data in tables with row and columns and are great when you need strong consistency and complex queries. NoSQL database store data in more complex, more flexible formats like key value pair or documents and are great for high speeds, large scale applications. The good thing is that AWS handles things like backups, software patchings, monitoring, and scaling for you in their managed database services. So that means you can focus more on building features and less on server maintenance. So choosing the right database service for your application can improve performance, scaling, and cost efficiency. So let's now look at some of the main database service AWS offers, starting with AWS RDS. So Amazon RDS, which stands for Relational Database Service, is a fully managed service for running traditional SQL database in the cloud. So with RDS, you can run popular database engine like MySQL, PostgreSQL, Oracle, MariaDB, and SQL servers without manually managing the underlying servers. AWS take care of things like backups, patching, and automatic failover. So you can also enable multi-AZ development uh, where RDS keeps a standby copy of your data in another availability zone. So if something happened to the main database, AWS can fail over to the backup automatically, which improves availability and reliability. So RDS is widely used in the websites, backend APIs, and enterprise systems because it provides the power of relational database, which much less operational headache. So overall, Amazon RDS is a great option when your application needs a reliable SQL database and you don't want to manage every details yourself. So another very important database service is Amazon DynamoDB, so which is a fully managed NoSQL database. So DynamoDB is designed for high performance and low latency at any scale. So it can handle a million of requests per second while still responding very quickly. Instead of table with fixed structure, DynamoDB stores data in flexible key value or document formats. So this makes it perfect for modern applications where data structures can change or where speed is more important than a rigid scheme. DynamoDB automatically manages scaling for you. You don't need to worry about adding more servers. AWS handles that in the background. So it's commonly used in mobile apps, gaming, e-commerce, IoT, Internet of Things, and real-time applications where con- consistent speed is crucial. So with built-in features like encryption, backup, and global table, DynamoDB is powerful choice for large-scaling NoSQL workloads. So let's move to the next one. So now let's talk about two more advanced database service, Amazon Redshift and Amazon Aurora. So Amazon Redshift is a data warehouse service. It is used for analyzing very large amount of data, often in terabytes or petabytes. Business use Redsheets to run complex analytical queries and get insights from their data, like sales trends or user behavior over time. So Redshift is optimized for fast querying on huge data sets by using techniques like columnar columnar storage and parallel processing. It's very useful for business intelligence and reporting. So Amazon Aurora is a high performance relational database that is compatible with MySQL and PostgreSQL. Aurora is designed to be much faster and more reliable than standard open source database. So it automatically replicates data across multiple availability zone, supports automatically backups, and can scale up or down as needed. So both Redshift and Aurora are great example of how AWS provides specialized database tools for analytics and high performance applications. So let's quickly summarize the key points from this video. So first, networking, storage, and database are the core building blocks of almost every AWS application. Knowing how they fit together is very important. So AWS VPC gives you full control over your network design and security, allowing you to isolate sensitive parts and safety expose public facing service. Amazon S3, EBS, EFS, and Glacier give you multiple storage options, from fast disk like storage to shared file systems and low cost archive storage, archive storage. RDS, DynamoDB, Aurora, and Redshift provides powerful database solution for transactional workloads, large-scale NoSQL apps, and big data analytics. So when you understand how to select and combine these services, you can design AWS environments that are secure, scalable, and ready to real-world use. So thank you so much for watching this video on AWS networking, storage, and database. I hope this explanation help you understand how these core AWS services fit together and why they are so important in real cloud architecture. If you found this video helpful, please like, share, and subscribe to support my AWS learning journey and to stay updated with my next video in this series. So this presentation was prepared by me, Akash Patel from Concordia University, Chicago. Very special thank you to my professor, Dr. Victor Govindaswamy, for your constant guidance, supports, and encouragement. Your teaching style and clarity really inspired me to create this content and share it with others. Thank you again for watching, and I will see you in the next video where we will talk about AWS monitoring, logging, and governance.